This is 2.4, solving quadratics by graphing. So in this section, we're going to merge Unit 2 and Unit 3 and talk about how we can solve quadratics by using our graphing skills that we learned in Unit 2. So in this first example, we have the equation x minus 3 squared minus 2 equals 2, and we'd like to solve it for x. So we're trying to get x by itself, or we're trying to isolate x. So we can do this a couple of different ways using Desmos and using graphing. The first thing we can do is we can take the left-hand side of this equation, so y equals x minus 3 squared minus 2, and graph it. And I wrote that in red because that represents the red curve that's on our graph. And then we can graph the other side of the equation. So we can say y equals 2. And I wrote that in blue because that represents the horizontal line that we see in our graph. If we do that, then what's going to happen is the red curve is going to hopefully intersect the blue line. The intersection points are going to lead us to our solution. So I'm going to put dots on the intersection points, and then I'm going to go down because we're trying to solve for x. I'm going to go down to the x value on the x-axis, and I get x equals 1 and x equals 5. For the graph on the right-hand side, what we did in Desmos is we just took our equation and wrote it exactly as we have it written, highlighted in yellow. And you can see that we hit the same two spots on the graph. We hit x equals 1 and x equals 5. So both of these methods could be used to solve our quadratic equation. And you may try and use like the one on the right as your primary method and the one on the left as a backup if your primary method doesn't work out so well or there's something weird going on. So let's try this with the next example. We're going to solve by graphing. So method number 1, I'm going to take the left-hand side of this equation, make it y equals negative x plus 2 squared plus 3. And the right-hand side, y equals negative 1. And I'm going to go into Desmos. So I'm going to graph the first y value. So y equals negative x, go back and check my equation, plus 2 squared plus 3. So there's my first equation. And then my second equation is y equals negative 1. And so again, Desmos is going to give you gray dots that represent the intersection points. So there are intersection points. And if we look up towards the x-axis, we can see that x equals negative 4 and x equals 0 are our two solutions. We can also see that in the points that we're given. We want the x values of the points. So x equals negative 4 and x equals 0. If I try this a different way, I can get rid of the negative 1 there. And instead of putting two different y equals, I can go ahead and just type in the equation as it's written and get my two vertical lines. For this type of equation, it's nice because Desmos will give you the gray dots. It won't always give you the gray dots, but this will. And we get x equals negative 4 and x equals 0. So I can hop back over here and put down that I have a solution of x equals negative 4 and x equals 0. Okay. Just to emphasize this a little bit more, here's one more example. This one, we're just looking at the graph with the parabola, the left-hand side. So where y equals 1/2 x minus 1 squared minus 4, and then y equals 4. If we look at the intersection points and put dots on them, and then look down to the x-axis, we get x equals -3 and x equals 5. And we can double check that in Desmos by going back to our equation and saying 1/2, and then we've got x minus 1, oops, squared minus 4 equals 4. And there are two vertical lines that pass through -3 and x equals 5. What we're going to do in class for the remainder of these is divide these last examples up. But if you're doing this on your own, go ahead and give it a shot and then check this OneNote sheet for the answers.